The world is a wild and unpredictable place. And isn't that absolutely amazing? Products can catch fire overnight. A back-of-a-napkin idea can change the world. An incurable disease can suddenly appear vulnerable. So many wonderfully improbable, never-before-possible breakthroughs are out there, waiting to be discovered. With Amazon Web Services and Intel, you'll be ready for anything. Ready to unlock a human genome, to safeguard our most valuable assets, to improve the way we communicate, to give every human a chance at a better future, to reach new speeds. Because you'll have Amazon Web Services featuring custom Intel technology to drive cutting-edge advancements. Because AWS and Intel engineers have worked together for over a decade to make sure you'll be ready. And because you'll have AWS's most innovative and powerful cloud service platform to help you make the impossible possible. That is the power of AWS with Intel. So go ahead, shatter conventions, explore the unknown, and ask questions that haven't been answered. With Amazon Web Services and Intel, you can charge toward the future ready for anything and ready to change everything.
Welcome to the AWS Summit in Stockholm. Let's give a big welcome to the Managing Director at Amazon Web Services in the Nordics and Baltics, Mr. Guido Bartels.
Good morning, Stockholm. Welcome to the AWS Summit 2019. I hope the registrations went smooth this morning. We're so excited to see you all here. A big thanks for taking time out of your busy schedules to spend a day with us. We're hosting the summit here in Stockholm for the 7th time, and I can assure you this is by far our favorite week of the year. Our team has again put in a huge effort to make this the biggest and best summit ever. So, the biggest it is, as you can see here for the numbers. We expect more than 4,500 customers and partners from all over the Nordics and Baltic region. More than 3 times the number we sold just 2 years ago at this event. So staggering growth. So simply incredible and humbling to see so many of you here. Now, before I get to the agenda, I want to share one of my favorite quotes from Jeff Bezos. So I'll let you read it for a second. I share it because I would like to think that we are enabling you to do some of the great innovation that's happening in this region. As we all know, the Nordics is one of the most innovative regions in the world. Sweden was just ranked second behind Korea as the most innovative country in the world, according to the Bloomberg Innovation Index. And this is not only reflected in the success of our global enterprises here, but also within the startup space, where the Nordics is one of the most innovative and most vibrant startup scenes globally. I often like to say this region is small in population, but big in innovation. Our objective today is to maximize the value to you as a learning opportunity. We have over 25 customers throughout the agenda today, and they will share their story of innovation based on real-world experiences, so that you can walk away with actionable insights to continue to deliver results on your cloud journey. I hope you'll find inspiration and learn from others during the day. So now to the agenda. The 35 breakout sessions span from business-focused topics to deep technical insights. And we have added more deep dive sessions, as this was a clear request from you from last year. Our goal is to provide content so that you can build your personalized agenda tailored to your particular interest and experience level. The keynote will be held by my colleague Ian Messingham. Ian is Director of Developer Technology and Evangelism, always loved that last part of the title. And he is a proper cloud veteran here at AWS, and a full-blown techie. He will give us an insight on how AWS can enable your innovation. And Ian will be joined on stage with some really exciting companies who will be sharing their AWS stories. Now, at the face of it, these companies don't have a lot in common. A bank and a dairy company from Norway who have led their respective industries for almost 2 centuries, and a 6 years young Swedish startup disrupting globally with their collaborative street-level imagery platform. But we're keen to have them join Ian on stage, as we think they're great examples, per the earlier Bezos quote, of how companies can unleash creativity and pursue their dreams using technology. Now, the fact that we continue to offer this educational event to so many for free is entirely thanks to our sponsors who have seriously stepped up this year to make this event a success. So I want to take a moment to thank our sponsors. First, our 4 global sponsors, who share our vision for helping builders build and contributed significantly to making today possible. As a company, and it's important to emphasize, that we realized from day one that we would not be successful without our partners in helping customers with their journey into the cloud. Today we have tens of thousands of partners globally as part of the AWS ecosystem of innovation aimed at helping you to build your applications on top of AWS. A special thanks therefore to Intel, Cloud Health, Datadog, and VM. Similarly, I want to thank our platinum sponsors, DXC Technology, NordCloud, and Rackspace. Also thank you to Accenture, who is supporting the AWS EBC, a one-to-one executive and expert briefing program which we're running here at the summit for the first time. Now take the time during the day to visit all our partners at the expo and discover how they can help you to keep you building. Now, before I wrap up with some comments about our ongoing investments in the Nordics, I'd like to briefly reflect on the shift in technology which we are going through right now. One that is unlike any other in our lifetime, and one that is happening at a mind-boggling pace. Today, millions of customers all over the world run every imaginable use case on AWS and leave the heavy lifting of the underlying technology infrastructure to us. As you can see behind us, we have customers in every kind of industry segment, and clearly we don't have enough time to go through all of them. I think it's perhaps more relevant for you to see how this fast-paced technology change is manifesting itself in the Nordics. how the collective footprint of customers, partners, and AWS is growing here. Today, we have tens of thousands of Nordic customers using AWS. Behind me, you can see some of them. And after we're working for AWS now myself for almost 2 years, I remained super impressed by the innovation going on here in the Nordics and how our customers help the world to become just a little bit better for ordinary people. Whether it be allowing patients to do video calls with their doctors via their mobile, turning your lamps on and off with the help of your voice, watching movies online, or as we'll see in the keynote later from Tine, connecting cows to the internet to improve milk production. We are very proud and humbled to be part of that innovation and those transformational journeys. Now, similarly, we're excited that you're building, our customers and our partners, a large community here in the Nordics. We have with 17 AWS user groups across the Nordics and more than 8,000 members. We have here one of the most vibrant user group communities across all of Europe. At these AWS user groups, you can meet with other AWS users to share ideas and best practices, get help, and learn about AWS services. So make sure that you also visit at the Expo the AWS community booth to learn more, find a user group near you and become a member, or start a new one yourself. Now, thanks to all of you, we also continue to invest in the Nordics. One of our significant investments was the opening of our first AWS infrastructure region here in the Nordics, which was the 5th in Europe. We have been open for business now for a little over 5 months, and we are very pleasantly surprised by the high demand. We have seen rapid growth from customers and partners across every kind of business, wanting to leverage AWS service from the new AWS region here. Customers like Scania, a global leader and provider of transport solutions, or Schibsted, a global leader in media and online marketplaces, or TV2, Norway's largest commercial media company, or Visma, one of Europe's largest software companies. All are already using the Stockholm region. Now, there are some very good reasons to do that. In addition to having very low latency to all of the Nordic capitals, access to a broad range of the most advanced cloud technologies in the world, and the opportunity to store data here in Sweden, customers using the Stockholm region also benefit from Europe's most competitive pricing for AWS services, like Amazon EC2, Amazon RDS. And also, as we will talk a bit more about in a minute, using this new region can help you reach your own sustainability goals. So with this new region, there's actually no reason anymore to run your own data center. We are literally just around the corner. Another significant investment was even more recent. As you might know, AWS has a long-term commitment to power all of its global infrastructure 100% with renewable energy. Last month, on April 8th, AWS announced it is investing globally in 3 new renewable energy projects. Once complete, these 3 projects, combined with our previous 9 renewable energy projects, are expected to generate more than 2.7 million megawatt hours of renewable energy into our global infrastructure. This is equivalent to the annual electricity consumption of almost all households in Malmö and Gothenburg, 2 of the 3 biggest cities in Sweden combined. What was even more relevant about this announcement is that for the first time, 2 of these 3 renewable energy investments are happening outside the US. And I'm extremely proud that we chose Sweden as the location for one of those projects. We will purchase 91 megawatts of power from a new wind farm in Bäckhammar, Sweden, and will deliver this renewable energy to the grid powering our Stockholm region by the end of 2020. But we're not only investing in our IT and energy infrastructure here, we're also investing in the local communities. And thinking long-term sits very much in our DNA. And that is why we're also committed to invest in the communities where our employees live and work. To support this commitment, we launched the AWS Hackathon for Good program, where we'll work with organizations across the Nordics to identify societal issues where technology can provide solutions, and we'll organize hackathons in their favor. The first AWS Hackathon for Good will happen late September, and as part of that, we'll collaborate with the Keep Sweden Tidy Foundation. I tried to pronounce that once in Swedish, won't do it, for their Nordic Coastal Cleanup Day. Now stay tuned for more information on this hackathon. It will be loads of fun. Last but not least, we're here to support you on your cloud journey. Since we met at our last summit, we opened a new office in Oslo, and we're now represented in Sweden, Finland, Denmark, and Norway. And just 2 days ago, on Monday, we opened our second office in Sweden, in Gothenburg. We also opened up, since we last met at the summit, 2 more network edge locations in Oslo and Copenhagen, which means we have now 6 edge locations across the Nordics to help you reduce latency for end users in the region. But as I also said at our last summit, we are far from being done investing and growing in the Nordics. So thanks, have a fantastic day, looking forward to meeting many of you, and let's now welcome our keynote speaker for the day, Ian Messingham.
Good morning, Stockholm. It's great to be back here in the Nordics. My name's Ian. I've been with Amazon for over 5 years, and today I lead developer technology and evangelism globally for AWS. And you can probably tell from my accent that I'm not actually from that far away from here. I'm from Yorkshire in the UK. But I'm pleased to say that over the period of my time at AWS and Amazon, I've been really lucky to visit the Nordics a lot. And I've learned a huge amount from the innovative software-based technology organizations that you have headquartered here in Sweden, Norway, and the rest of the Nordic countries. So I'm really, really happy and excited to be back here today to talk to you. Although I've learned a lot over the course of the last 5 years from visiting customers here, today is all about us giving you an opportunity to learn more about AWS and how you can put the platform to work for you. And we've really focused hard this year on trying to add more technical depth to the agenda here in Stockholm. So I hope that you will visit some of the breakout sessions, particularly some of the deep dives that we have set up for you today. Please reflect on those sessions and provide us with feedback afterwards and let us know how we can continue to optimize the agenda for you. We're trying to deliver the deepest technical content for the advanced audience that we see here in the Nordic region. During the keynote this morning, I'm going to cover a quick tour of recent innovations within AWS and the AWS platform and services portfolio. Before I get on to the first part of that, though, I just wanted to talk briefly about how AWS got started. We launched our first services back in 2006, services that are still extremely popular today, services like Amazon EC2 and S3. And our objective here was to provide builders, software developers, and software architects with a toolkit that they could use to accelerate the rate at which they could build new applications and experiment with new business models. But for Amazon itself, AWS was an experiment in its own right. We genuinely didn't know at day one whether or not this new idea for industrializing or turning IT services into a utility would be popular with customers. And I think the level of attendance here today demonstrates that that was a pretty helpful experiment to run, and the business turned out to be pretty successful over time. What we've done over the course of the last 13 years, of course, is iterate a lot. And today we have over 165 different services covering pretty much every conceivable aspect of software and IT operations. If you want to build applications today, you can almost guarantee that there's a service in the AWS portfolio that will help you do that more quickly. And that iteration doesn't just extend to services, it also extends to the AWS global infrastructure footprint. Today we're operating in 21 geographic regions around the world, and each one of these geographic regions, as a lot of you will know, contains a construct called the availability zone, or multiple availability zones in fact. And this allows customers like you to build and operate applications that have really high durability and availability characteristics whilst remaining in that specific location. And of course, that can be really important for things like controlling latency, ensuring that your customers have the best possible service experience, or meeting critical regulatory or legislative requirements that you might have. We also have 4 more regions that have been pre-announced, and over the course of the next few years, we'll be delivering regions in Milan, Cape Town, in Jakarta, and also in Bahrain. So you'll be able to serve even more parts of the world with low latency from those regions. Iteration, of course, is something that also applies to individual services, and I'll dive into this in a lot more detail during the latter part of the keynote. But I wanted to just recap some of the work that we've been doing to extend some really important parts of the portfolio. For example, in databases, we now have over 14 different database options. Customers can use those to ensure that they have the right database technology with the right fundamental characteristics to serve different types of workloads. In storage, we have the most options for storage of any major cloud provider with block, object, and file storage. In the file storage category alone, we have support for NFS, for Lustre, which is a popular file system for supercomputing and parallel workload applications, and also for Windows Server with our new FSX for Windows Server service. And we have data transfer services as well, of course. And then on information security, this, of course, is a huge area of investment for Amazon Web Services. We recognize that it's a #1 priority for customers, and we often describe information security as job zero at Amazon and at AWS. We offer more than 200 different security and compliance features to customers. One of the most important of which, of course, is encryption capabilities. And our CTO, Werner Vogels, who a lot of you will have seen here last year, has made it a mantra to repeat to customers as often as possible that you should encrypt everything. Encrypt all the data that you put in the cloud. Not only protects it from attackers, but it also obfuscates that data and makes sure that nobody can access it without the key. And of course, those keys are the literal key to cryptography. We launched a service called KMS, the Key Management Service. This integrates with 54 other AWS services, and it allows you to encrypt data at rest using AES 256-bit keys with key auditing, key rotation, key deletion capabilities. It's a really, really important service for customers that want to ensure that they are operating services in the cloud in the most secure way possible. So encrypt everything and learn about services like KMS and how you can put those services to work to protect your data. In total, we offer encryption across 116 different AWS services, which is roughly 3 times more than the next nearest provider. So it's a really, really important area for us. So, for me, the highlight of these keynotes is getting really, really exciting customers on stage to talk about what they've built with the AWS cloud. It makes it real for me, and I think it's so inspiring to hear from customers how they've moved forward their goals by using innovative new technology. And I want to invite my first customer to the stage in just a second. This customer comes from a segment that is really well known for having a really high priority on information security and compliance, and it's the financial services segment. So I'm really, really delighted to invite to the stage the CIO and EVP from DNB, which you will of course know as Norway's largest bank. It's Nikolai Rai. Nikolai, please join me on stage.
Thank you, Ian. I'm delighted to be here today, and I'm really looking forward to share some of our story with you. Ian is saying that we're the biggest bank in Norway. I like to say we're the world's biggest bank in Norway. I say that with a lot of irony, though. It's because we like to have somebody up the chain that we can get to talk to, so things happen. But with Amazon, it has really proven that the team on the ground has helped us. So, to tell a little bit about myself, I run IT for the retail bank of DNB. I joined DNB about 2 years ago to help the mission of transforming DNB from a bank to a technology company with a banking license. And I'm here to tell you about how we use AWS to build our new mobile bank. Until about 3 years ago, our customers was really happy with our mobile bank. And it was built in 2009, so for me it was a surprise joining DNB and seeing the numbers and the customer satisfaction on the app. But it basically, people didn't like change, but when everything else started changing, you got the Uber and the Spotify and all the other apps, our customers got impatient with our app. So we decided to start a project to build a new app on the old monolith stack. But then at the same time, DNB decided on a cloud strategy. So we paused the project, and about 2 years ago, we restarted that project to build our future app. The app is going to be our corner piece in our customer interaction. The mobile bank will be also how we're going to interact with non-DNB customers, using APIs from other banks. And we have converted the team into a stable team. Transforming the app from the old app, we had an old app, and showing the graph here, the lowest graph is the logged in users in the app, and the high green line is the numbers just using the app to check the balance without really logging in. The red line shows how we converted the users into the new app. We onboarded employees early, about 10,000 testers. It's a great asset. It's cost efficient to use your own employees for testing, and it also gave ownership to all the employees across DNB. Close to go live, we run break the bank sessions. We basically tried to stress test the value chain by trying to do as many logins as possible in 1 minute, running big sessions in our offices, and also to try to do as many payments in the same minute as possible. And the one closest to the countdown would win an iPad or an iPhone. When we went live, we didn't do a big bang. We did a stage rollout about a week. And then when it was available to everyone, we started doing auto updates, and we even used SMS to nudge some of the users over to the new app. The old app is still there, but not available for new registration, but it served the purpose of those having old iPhones that can't upgrade to the later versions. We have about 2 million customers on the retail part of DNB, and we have now seen about 850,000 of them in the new mobile bank. We have 1.3 million daily logins, and we see about approximately 400 unique users a day. So we see that users are using the app more on a daily basis, and we also see that they're using it for more things. So going a bit into the app. Our focus is to utilize all the services in AWS, thinking that we really want to be on the frontiers of what AWS has to offer. So we are not afraid of a lock-in position. For security and networking, we used Advanced Shield, CloudFront, Route 53, and then we have a Lambda that calls our login engine. That one is built with Ping ID. It supports our common ID, Bank ID, but also biometrics and local things from the app. All the features in the app is built using Lambdas. So we have different Lambdas with different storage types, depending on the use case. The last time I checked, we had about 42 different Lambdas. So it's a pretty big setup. The Lambdas runs in private subnets, so we can segregate the data. This shows at the month of April. So basically, we can see that this is really cost efficient. So when you guys sleep, we don't pay anything to Amazon. That's really smart. We also built an API layer. So all our custom-facing projects will utilize a common layer of APIs. These APIs are built by a central team to keep a strict governance and also ensure that we can reuse this for other apps. And then, of course, being a bank, we already have all the services we need on-prem. So it's basically to present this and present it to the customers through our app based on the cloud. So we have a strategy that we encapsulate the old to protect the old cores. So we have then basically two API layers. One API layers on-prem and one API layer in the cloud, and then we ensure a good orchestration between the two. So what's next? In addition to the mobile bank, we run a chatbot that speaks Norwegian, which is nice. It runs on the external pages, and it runs on the internal pages. This is then running, coexisting with the old platform from AWS. We created an app to support small businesses, and our open bank is also running on AWS. We also created a team that is building on Kafka in AWS for our customer insight projects. And next is to extend the mobile bank into browser version. It will coexist with the current NetBank, and our goal is to only build new features on the AWS platform and then make them coexist with the old one. We also started the journey to move our external pages, our web presence, to AWS, to build our new customer experience platform. We have chosen Adobe for this, and what's really important about this journey is not just to move the external pages, but it's basically to create an ecosystem that can coexist and present information from the different technology stacks. So you as a user on the dnb.no page will not know where the technology is running, so we need to have a good journey. So this was a peek into our cloud journey. If you have questions, just reach out. We are happy to share with you guys. Thank you.
That's great. What a great story. Thank you so much, Nikolai. And I think that's a really helpful piece of insight to tackle one big myth about serverless application development, which is that in some way, serverless development paradigms are not ready for production. Okay? Not only is this an app that's in production at scale, but it's an application that's in production at scale in a regulated industry with some really, really relatively complex integration requirements as well. So if anybody ever tells you that Lambda is not ready for production, I think we should send them back over to this video and demonstrate that's definitely not the case. So what you've heard there is a little bit about building new applications in the cloud using a hybrid architecture pattern. Of course, the other way in which customers on-ramp onto AWS is through migration projects. And I just wanted to briefly talk about some of the tools that we have that are intended to help customers move to the AWS cloud even more quickly. In helping customers migrate over the course of the last several years, we've built a lot of services that are intended to make it easier for you to get data into AWS. And of course, these services can also all be used in reverse to help you take data out of the platform as well, overcoming concerns that you might have about lock-in or about the difficulty of moving your applications out of the platform. We can dispel those as well by pointing out that these services work in both directions. A few of the highlights here are things like the AWS Snowball. It's a luggable, ruggedized storage device that holds 100 terabytes of data. You can order it from the AWS console. It will turn up at your location where you've specified it to be shipped to. You can plug it into your network, copy your data onto the device, and then we'll collect it and take it back to an AWS region and load that data into Amazon S3 for you. So it's a high bandwidth, pretty high latency device. It takes a few days to get the data over to us. If you want to go even bigger than that, we have something called the Snowmobile. It's a 50-foot long container truck with 100 petabytes of capacity in it. You can use this to move massive amounts of data to the cloud. One of the early customers was a satellite data provider in the US that literally drove this truck up to their ground station with its data center adjacent to it, decanted petabytes and petabytes of geophysical data into the device, drove it back to AWS, uploaded all that information to Amazon S3, and then started to make their data products available in the cloud, which were derived from that large data set. And then if you're interested in accelerating migration of data across networks, obviously a very, very common pattern as well, we recently announced something called AWS Data Sync. This is a mechanism for synchronizing data sets from on-premises infrastructure with data sets in the cloud. So you can keep those in sync for migration purposes or as part of a disaster recovery strategy. It makes it roughly 10 times faster to copy data to the cloud than using well-known open source synchronization tools like rsync. So it's highly optimized for that particular use case. Of course, lots of the things that customers want to move are not just large collections of files or large collections of objects. They're structured databases, relational or even non-relational databases. And for this, we have a service called the Database Migration Service, imaginatively named. It's moved over 130,000 database instances to and from AWS. It provides automated schema assessment, a mechanism for triaging complex components of the migration that it might not be possible to handle with full automation, and then a mechanism for zero downtime data synchronization between your on-premises database infrastructure and databases of various types that are running up in AWS. As I said, it's for OLTP relational workloads, it's for data warehousing workloads, and it's also for non-relational database workloads, like, for example, MongoDB to DynamoDB is one of the supported migration patterns that you have there. Very, very popular service with customers. And those databases, of course, support applications. And just to highlight two areas where we've seen a lot of activity from customers undertaking migrations. With SAP, we've been collaborating with SAP since 2011 to make AWS a really good place to run large-scale SAP applications. A few years ago, we announced and launched something called the X1 instance family. It's a multi-terabyte memory instance type, which is intended for large-scale implementations of SAP HANA, their in-memory database technology. So you can run that application very capably on those very large instances. And then on Windows, maybe surprise you to hear that AWS is the most popular place to run Windows-based workloads in the cloud. According to a study by IDC, we have almost double the number of Windows workloads running on AWS as the next nearest competitor, Microsoft. So we're a really, really popular place for customers to bring their Windows workloads. Of course, it's a truism, right, that it's very, very difficult to build a complex system. But if you wait around long enough in IT, you'll find that complex systems just naturally evolve in your environment, right? Anybody disagree with that statement? Okay, that's good. So we're all familiar with the kind of complexity that exists within long-term enterprise IT operations. When I worked back in telecoms, I was working for a mid-sized carrier. We had well over 3,500 applications. And to be honest, we didn't have that many more employees. So we almost had one application for every single employee in the company, which had evolved over a period of time. And even if we'd wanted to move all of that to the cloud, this predated the cloud, but even if we wanted to move that all to the cloud, we simply wouldn't have been able to do that overnight. That would have been a long, drawn-out process of figuring out the benefits case for moving each one of those applications and maybe taking those applications down different paths. Maybe it's rehost, maybe it's replatform, maybe it's retire. What we've tried to do at AWS is create a portfolio of services that really simplify the process of implementing those decisions once you've taken them. So if you decide that you're going to stage your IT migration, maybe run in this hybrid operating model for an extended period of time, we have a service called Direct Connect. This allows you to establish private, high bandwidth, low latency network connectivity from data center or wide area network directly into an AWS region. And you can use that to extend your data center, desktop, or wide area network into the cloud and operate applications that span those two environments with really, really good performance characteristics and isolation for security reasons. We also recently announced, this was at reInvent 2018, so at the end of last year, a new service offering called AWS Outposts. This is currently in preview. This allows you to order EC2 capacity and have it shipped out to a location of your choosing. This EC2 capacity is then manageable via a regional console which is assigned to that particular AWS Outpost infrastructure. And you can then launch EC2-based workloads remotely on that infrastructure that you've got deployed, be that in a data center, in a manufacturing plant, or even somewhere really remote, like say on an offshore drilling platform in the oil industry. And this allows customers to use the familiar characteristics, benefit from the familiar characteristics of EC2 and other EC2-based services like RDS, for example, but to do so in a way which really attacks the latency characteristics of the app. and also allows for disconnected operations. So if for some reason you don't have network connectivity back to the cloud, you can still access those applications and use them with those low latency characteristics. That's Outposts. It's in preview right now. If you're interested in experimenting with that service, I recommend that you sign up for the preview. We'd really like to hear from you if you have a use case for that kind of technology. And then lastly, VMware Cloud on AWS, a service that was announced quite a while ago now, and VMware have been working with AWS to expand the regional footprint for this service, making it available in a lot more regions around the world. And lots of customers are using this service today. The reasons for that really are that you can take the expertise and tooling that you've developed around VMware tools like vCenter or vMotion to teleport your workloads from your on-premises infrastructure up into the cloud. And you can do that in a way which doesn't require you to retrain or re-educate or reskill anybody in your operations or deployment team. Okay, so if that's an important criteria for you, I recommend that you take a look at this particular service. And you'll see we have customers all over the globe that are using VMware Cloud on AWS to take advantage of those benefits. Okay, so I now want to move on and talk about new application development and some of the approaches that you might take towards refactoring or recreating applications in the cloud. And this is a journey, believe it or not, that Amazon itself has been on. Back in 2002, Amazon.com was running on a large C++ monolith. The whole of the retail experience was wrapped up in this really large code base, which was, by definition, tightly coupled. Okay? And there are lots and lots of applications out there today that have been built using the same kind of approach. And this throws up a few challenges. One of the challenges is the rate at which you can add additional features or make changes to the application gets degraded. And it gets degraded for a couple of reasons. One of the reasons is it becomes increasingly difficult for any one systems designer or software architect to maintain a cognitive model of the whole application, right? It's just too complicated. So that increases risk. Naturally, there are parts of the application that are less well known. The second thing is testing becomes increasingly complex and increasingly time consuming. I make a change to the code base over here, and my test suite coverage ends up being really, really substantial. That can take a long time. Can slow down iteration. It can actually make identifying bugs and issues with software inside this monolithic architecture a lot more difficult. The third area, of course, is that you tend to have tightly coupled integrations within this sort of architecture, and that means that things like component failures or latency, they'll propagate through the whole application. Okay, and you can find that your application becomes increasingly fragile as a result of those characteristics. So the solution that a lot of organizations are turning to in order to overcome some of these challenges is microservices. And this is a journey that Amazon itself has been on. Even within a service like Amazon S3, we started with around 8 different services inside S3. But today we have over 130 different service components that you're taking advantage of when you use various features of Amazon S3. That's just one service. Okay? So that's a model that we've used a lot. There are a lot of benefits to this kind of approach. The ultimate benefit really is it makes it much easier to establish an ownership culture alongside your software, much easier to identify who owns a particular service. And that allows you to move to a DevOps type model, the kind of model that we at Amazon often describe in these terms. We say, if you build it, then you run it. And you can have a small multi-function, multi-capability team that is running an individual service, understand that service really well, and that can therefore drive up the velocity at which you can introduce new features. And if you talk to customers, as I do, about the benefits that you get from this kind of architecture, this velocity is really, really key. It's the ability to move quickly. What is interesting, I think, about this kind of pattern, of course, is it allows different services to choose different targets. You don't necessarily need to have highly standardized infrastructure, and you can run different services on different infrastructure types that are most suitable for the characteristics of the service. And from a compute perspective, that might mean things like running some services on EC2 instances, running some services inside containers, and running some services on event-driven compute. And in our case, that would be AWS Lambda, of course. I just want to talk about each of these different options in a little bit more detail and give you some flavor of what we're doing here. So in instances, these are the raw foundational building blocks of the AWS compute services. Gives you the ability to run virtual machines inside the cloud. Very, very simple. We call these virtual machines EC2 instances. We launched the first type back in 2006, as I said. And since then, we've been iterating on this service, adding loads more different instance families for different types of workloads, adding additional capabilities, like different processor types that enable you to optimize for cost, or high memory footprint instances like the ones I talked about for SAP, or advanced accelerated computing capabilities with things like GPUs, FPUs, floating point units, or FPGAs, field programmable gate arrays for special purpose applications where you want to accelerate specific algorithms in silicon. Today we have over 200 combinations of instance types and sizes that you can pick from. So you can optimize for your workload, driving down cost, driving up performance, and ensuring that your application is running on the most optimal underlying platform. So if you're not familiar with some of these different options, I'd really advise you to investigate them. You can save a lot of money by being proactive with things like instance selection. That might be choosing one of our new ARM-based instances with the Graviton processor that we developed at Amazon Web Services. Or we might be moving a workload onto the latest generation of instance type, maybe from an R3 to an R4, which will drive down the cost per gigabyte of memory. It's a very, very simple change to make, and you can immediately attack your AWS bill if you do that. Counterintuitively, we actually want our customers to spend as little as possible on the platform, not as much as possible. So how do you manage that compute? One of the most popular techniques today for managing compute at scale is, of course, containers. We're providing here, or the technology is providing here, a mechanism for encapsulating applications and dependencies in a way which really speeds up and simplifies the process of deploying and scaling applications at scale. We have several different service options here. The first and longest lived is something called Amazon ECS, the Elastic Container Service. It's a fully managed container scheduling engine and management system that is tightly integrated with many AWS services. If your priority is to run containers at scale with the tightest integration with the rest of the AWS platform, this is probably the best choice for you. More recently, we announced something called Fargate, AWS Fargate. This is an execution type on top of ECS. It allows you to dispense with the overhead of running container instances. So rather than launching a cluster of instances and then placing containers onto them, with Fargate, I simply launch containers with a task specification and some attributes to specify how many I want, which networks I want them in, and which additional features I want them integrated with, such as load balancing. And then Fargate will deploy those containers onto a fully managed substrate on my behalf. I don't see or pay for any EC2 instances, either see them in the console or see them on my bill. I simply pay for the execution time and characteristics of the containers that I'm running. How much memory or CPU do my containers consume, essentially? Really, really simple, a serverless model for containerized apps. And then we've also announced, slightly more recently again, a service called EKS, the Elastic Container Service for Kubernetes. And this is a mechanism for making it really, really easy for customers to run Kubernetes container clusters inside the AWS cloud. The biggest benefit here really is it gives you environmental consistency from laptop to a potential on-premises deployment to deployment of your containerized applications within AWS. There will be no difference in the specifications or the APIs that you use to integrate with those three different environments, and it provides a fully integrated, cohesive tool chain for you. We're today extremely active in the CNCF, the Cloud Native Computing Foundation, which is the governance body for Kubernetes and associated projects. And in fact, we've got a large team on site down in Barcelona right now at KubeCon, which is the CNCF conference here in EMEA. And I guess you've all chosen to come here and see us instead, which is really kind of you. But if you were active in the Kubernetes ecosystem and at that event, you'd be able to meet with AWS experts and talk about the service in more detail. And we'll have a breakout later on today where you can dive into this in a little bit of detail as well. These options mean that many, many customers are running containers on AWS today, and it's becoming an increasingly popular deployment target for customers that need to run applications with highly elastic scaling characteristics, very low latency, and want to integrate their tool chain for things like continuous integration, continuous deployment, testing, sandbox environments. It really simplifies the process of dealing with some of that heavy lifting. Here in the Nordics, we have a customer called Checkout, which is a payment service owned by OP, which is Finland's largest bank. They're using AWS Lambda ECS and AWS Fargate to run their containerized applications on AWS today. And you can see from this slide that we have other customers globally as well, including McDonald's, who are running much of their restaurant management infrastructure on ECS today. So just to recap, orchestration options, ECS, or the Elastic Container Service for Kubernetes, ECS. Compute engines, you can either use raw EC2 or you can abstract that away with Fargate. And then for image repository, so for managing the Docker images that you need to use this kind of operating model, then we have ECR, which is our container registry. I just wanted to quickly return to serverless. We've heard a little bit about this already from DNB, so I'm not going to drill into this in too much detail. But I would just say that for AWS and Amazon, there's way more to serverless application architecture than just event-driven compute. You know, we're interested in things like message passing patterns. We're interested in things like how do we manage our data tier, our persistent data tier, in a way which removes the need for us to manage EC2 capacity or underlying operating system capacity. And we're also interested in the tooling wraparound, things like continuous integration and continuous deployment, metrics and alarms using serverless approaches. So we have a complete portfolio with over 47 services that integrate with AWS Lambda to provide these other features. If you've never investigated this kind of development paradigm, I would really recommend that you take a look at it. Spin up one of the workshops that we have or experiment with a tool like SAM or SAM Local. It allows you to use many, many of these tools directly on your local laptop in a development environment, and you can get started with the platform and understand what's possible. And again, lots and lots and lots of customers using AWS for serverless apps today. Now, in this mixed model, where we've got many, many microservices communicating with one another, one of the challenges is connectivity and standardization across these different communications channels. And this is something that we've been hearing from customers internal to Amazon and AWS, but also from external customers for quite a while. Customers want to be able to implement consistent communications management. They want visibility of the interconnects between these different application components. They want capabilities like failure isolation, circuit breakers, protection from cascading failures in this services architecture. And they want fine-grained controls over things like deployment for, say, canary deployments of different services inside what is essentially a mesh of different application components running as independent services. So to tackle this, we created something called AWS App Mesh. This is a high-performance service proxy. It uses an open source component called the Envoy proxy, which is written in C++. Very, very high performance. You can use that as a standardized mechanism for providing interconnectivity between different microservices components, whether those are running in containers or whether they are running on other targets. This allows you to manage and instrument the control plane for connectivity between your different components and have complete visibility over how those components communicate with one another. Also handle things like granular traffic control to reroute traffic between different services on demand or as part of deployment or recovery operations. So it's a really, really powerful tool for tackling one of the biggest challenges in large-scale microservices deployments today. Okay, before I invite the next customer to the stage, I just want to talk a little bit about database technology. I've already touched upon this briefly in the context of migrations, but what is it that you can migrate to if you choose to build and run your applications in the AWS cloud? And we have an increasing set of options here. There's a big trend in the industry to move away from proprietary commercial engines to open source engines. Much of the push factor here relates to licensing terms and high cost associated with traditional enterprise database vendors, okay? And also some of the business practices that some of these commercial vendors exhibit. So we try to provide a broad range of customers, both commercial and open source, to enable customers to move their data tiers, relational and non-relational, to AWS to escape some of those relationships. One of the most popular targets is a service called Amazon Aurora. This is a MySQL and Postgres compatible database engine which was custom built by AWS to address some of the challenges that are present in more traditional database architectures, the kind of architectures where you might have passive standby nodes and active nodes. With Aurora, we dispense with that approach. You can have a large cluster of instances, all of which provide read-write access to your data. And because you have a large cluster of instances, you have very, very high durability, very, very high availability, and really excellent failover characteristics. If there's a failure in your active access node for the data, one of those read replicas will very quickly pick up that role and ensure that your application is not interrupted for any extended period of time. And it will do so in a way which is handled gracefully if you're using the right kind of database drivers at the front end. And it does all of that at about 1/10 of the cost of traditional legacy enterprise databases. It's an incredibly popular tool amongst AWS customers. And if you look at these customers, you might notice that a lot of them are customers, by the nature of their business, scalability is a really important characteristic. If you think about customers like Supercell, for example, headquartered up in Helsinki, ultra high volume mobile gaming, and they're using Aurora as a component of their architecture to support that. Or PlayPilot, they're a streaming aggregator here in Scandinavia, migrated their catalog database from PostgreSQL to Amazon Aurora. They can now automatically scale on demand, and they also cut the cost of their operations by about 30% by doing that as well. And then globally, we've got customers like Dow Jones. They're shortening load times for market data by building on top of the really high performance characteristics of Amazon Aurora. So really, really popular service. The service has been doubling in terms of utilization over the course of the last 3 years. But there are other options, okay? And in this area, what we're talking about is purpose-built databases. And we've put a lot of time and effort into building databases that fit precisely against very specific use cases. So I'm just going to dig into a few of these by way of example. The first is DynamoDB, an ultra-high performance, low latency key value store that also supports a document access paradigm. We've added some advanced features to this recently, including global tables, so you can distribute your DynamoDB tables globally for durability and latency reduction, on-demand backups, point-in-time recovery, and also read-write capacity on demand, which is essentially auto-scaling of performance capacity for DynamoDB tables, and you'll be billed in accordance with the amount of read-write units you're consuming without having to pre-provision or manually provision that capacity. Very, very popular service. Again, very, very widely deployed, especially in high-performance, high-scalability use cases, where those characteristics are really important. We've also recently announced a couple of new services that make use of blockchain technology. And for a while, blockchain has been, to put it not too bluntly, a solution looking for problems. Okay, so you see a lot of people sort of reversing blockchain into solutions that could well be very well serviced by a traditional document or relational database, which makes you think, why do people want it? But there are definitely valid use cases. We've been doing a lot of research on this. We've uncovered 2 primary use cases for blockchain, and we've launched services that are intended to make these use cases much, much easier for AWS customers to service. The first is ledgers. This is a situation where you need to have an immutable record of all transactions that are taking place against your persistent data store. Regulated industries are one example. Gaming is another example. Third example might be things like inventory tracking. With QLDB, the Quantum Ledger database, we use an append-only immutable journal for tracking all changes that are made to the database. We cryptographically sign each one of those entries, and we store those cryptographic signatures on a blockchain. It's completely transparent, and you as a customer have full visibility into the entire lineage of your data. How did the data get into this state? You can wind back through that cryptographically verifiable transaction log and see all of the transactions that led to your data having a particular state at a particular point in time. It's actually technology that's been used internally within Amazon Web Services for a long time, but we've now made it available to customers for that specific use case type. It's currently in preview, so if you are interested, you can sign up for that preview via the console. And then the second common use case that we heard from customers was a use case for the more familiar distributed trust problem that is solved by blockchain technology. There are two very popular frameworks here. One's called Hyperledger Fabric, and the other one's called Ethereum. And they support capabilities like smart contracts, for example. Okay? And what we've done here is create a managed service to dramatically simplify the process of deploying these popular blockchain frameworks. Hyperledger Fabric is available right now, it's generally available, and Ethereum will come very soon. We believe these are the simplest and easiest way for customers to deploy these popular frameworks onto AWS resources. And then the other important use case, of course, is analytics. We're going to dig into this very, very quickly. So the basic issue here is that customers want to get more value from their data, and that customers are aggregating data inside AWS in order to do that. The concept of a data lake is not a new one, and what we've seen is that tens of thousands of customers are using Amazon S3 as a foundational technology upon which they will build aggregation capabilities for their enterprise or startup data. And there are, of course, a few reasons that AWS is very popular. Amazon S3 is very popular for this particular type of use case, not least security, compliance, and audit capabilities, but also the fact that it's a serverless data storage service. You don't have to add capacity. You can effectively tip an unlimited amount of data into the pool, creating a huge lake of data, and you have very little management work to do in order to implement that kind of system. On the same kind of theme, in reducing the management overhead of setting up the other important components of data lake infrastructure, we announced a service at reInvent last year called Lake Formation, which is also still in preview. This allows you to define data catalogs, to define security policies, and then apply those over all data resources within a particular account, essentially codifying the creation process for data lake infrastructure within AWS. So we have a very broad platform for building analytics services around data sets that are stored within Amazon S3. The platform includes Amazon Redshift, of course, which is our petabyte scale data warehouse. We've also been working on making internal improvements to this service, and today Amazon Redshift is roughly 10 times faster than it was just a couple of years ago. We added a new feature quite recently to improve performance for concurrent queries, which allows us to add additional hot pool capacity into your Redshift clusters to optimize query performance when you have concurrent access to your clusters. Again, an area of technology that is moving very, very quickly. And another big change that we've seen, of course, is a real shift towards streaming analytics. We have a portfolio of services for this. Kinesis, which is a service that's been around for quite a long time. This is for high volume, high performance, high reliability data ingest at any scale. So you can ingest records into AWS with Kinesis and durably store those inside other services like the Elasticsearch service that we provide, inside Amazon S3 as a foundation component for a data lake, or indeed inside Amazon Redshift. Those are features of the Kinesis data firehose. At reInvent, we also announced a new service for managed streaming for Kafka, a popular open source streaming framework, which is currently in preview. So if you're interested in that service, I would recommend taking a look at that. To talk a little bit more about the role that streaming analytics can play in architecture, I want to invite another customer to the stage. This is a really interesting area of agriculture technology. So Tine is Norway's largest producer, distributor, and exporter of dairy products. And to tell us a little bit more about the work that Tine have been doing with AWS, I'm really, really pleased to invite a great speaker to the stage, Mette Roald, who is the head of CRM and business development at Tine. Mette.
Hello, everybody. Hello, Stockholm. I am so thrilled to be here today to be able to talk to you about cows and the intelligence of cows. It's really exciting for us as a dairy company, and especially as a Norwegian dairy company, to be on stage here in Sweden. And I will do my very best to give you an introduction of what we've been up to the past years. My name is Mette. I've been working in agriculture and for TINE now for about 4 years doing our business development. And here today, I'm representing Mimiro as a humble member of the board here. I have some awesome colleagues joining me here today, Torkil and Rune, and feel free to reach out to us at any time during the summit today, because we'd love to talk to more people about what we're doing. So when I joined TINE, I didn't really have any experience in agriculture. So I deep dived into our value chain and also how we can start making more money, what our growth opportunities are. I quickly became really curious and impressed by the amounts, types, and data that I learned that we possess through our owners as cows. And this data is now turning into intelligence and is the basis for some of the new ventures that we're actually doing. So for a small dairy company from Norway, let me take you on this little journey that we've been on to as well. A little history lesson first. TINE is a very small company on a global scale, but we are actually Norway's largest dairy company. We're owned by about 8,000 farmers, and we have annual revenues about $2.7 billion per year. Our roots go back to 1856, and now we have a value chain that goes all the way from farming to bringing products and services into your homes. Even since 1898, we've been collecting data from each of our cows. And what I learned when I started in this industry is that the strategic thinking is really unlike a lot of other places, because farming operations are handed down from one generation to the next. So the long-term strategic thinking is different here. And this is really important for our data collection, having a collective mindset and being able to share the data the way that we can. And for decades, our farmers have been collecting this data, and they've been sharing it on an individual cow level. That's really important for us. We've been constantly adjusting the technologies as to how we've been gathering this data. So we've been using punching cards, handheld terminals, going over to IoTs, and going into the internet and applications. And now we're on to automatically gathering this type of data. Did you guys know that this little creature here has its own health card? It's amazing. It actually does. I don't even think I have my own health card. But they do, and it contains a bunch of information. So we collect, by law, information about its parents, grandparents, birth, who the farmer is, who the vet is, the medical history, the milking data. All of this goes on to the cow's health card. And it really follows it from birth and throughout her entire life. Now, TINE has been consolidating this data on a national level for decades. And we've been conducting systematically research on this for decades as well. We've been implementing the results into our operations, and it's improved our farming efficiency, animal welfare, and also our milk quality, not the least, because that is what we as consumers put inside our bodies. But our farmers don't just collect what is required by law. They're collecting a huge amount of information besides what goes into the health card. This type of data is what we see going into the cow, what goes on inside the cow, what comes out of the cow, and also the environment. Types of data here consist of, for example, the food, what kind of nutritional values it has, how much the cow is chewing, what the cow is chewing, again, whether it's hurt, whether it's feeling sick, how we're treating it, and again, the quality of what comes out of it. So we're able to measure all these different parts, and we're trying to measure even more around the cow now with the movements, where it's moving, the temperatures around it, the weather and everything that affects the environments. Just to put the data into perspective a little bit, we have about 200,000 cows in Norway. Now, from the data that we've collected by law, just from the milking observation, annually this has given us 2.5 million data points per year. However, nowadays, about 50% of our cows are being milked through robots, and that means that a cow can choose freely when she wants to be milked. Most cows choose to do this 2 to 3 times per day. So again, for the same observation, just by the milk, we can now measure about 175 million data points on that same observation. I knew this fun fact before I started in agriculture, and a cow does have 4 teats. So just that observation right there, we can even multiply it by 4. And that is the type of data that we're getting into our systems, just really rapidly growing now. My point is that as technology is progressing now, we're going to see a massive growth of the amounts of data around a cow. And that was really our challenge as a company. We had to figure out how we could leverage the data coming in, our experiences in the research that we've done on this, and at the same time speed up our solution and our organization around this. So in 2017, we jump-started our business development project on this to see what options we had going forward. And we really wanted to develop the next generation of tools for our farmers based on new technology. Our solution turned out to be Mimiro, an innovation-based technology company developing full-service farm management systems for farmers, a company that we spun out of Tina. Because just like we walk around with our gadgets or put into apps what we're eating or how we're sleeping or what we're doing, we're trying to be the best versions of ourselves. We really want our farmers to make their cows the best versions of themselves. So Mimiro uses the data from the agriculture to improve the farmer's productivity and profitability. Our farmers are now able to access and interact with their data and insights through simple interfaces that you can see some examples of here. We base this on our platform and our applications, and we will have services for the farmer within the status of their productions, the tasks that they need to be doing, operative advice in order to make them even better going forward, and also a digital community. To deliver this, we've chosen AWS because we wanted to build quickly, we wanted to scale, and we wanted to have the flexibility into our new systems. So this choice has made us be able to save operational costs on the technical side, and we're now speeding up the way that we're building features and also applications and can have even greater customer interaction than what we have been able to do forward. Let's take a look under the hood on how we're doing this. This is just a simplified view of our baseline architecture. It's highlighting really our core principle of building asynchronous, event-driven microservices. This is what we call our architecture 1.0. We are right in the midst now of a transition because we see with our strategic vision, we want to keep our core on the event-driven asynchronous architecture, but we're ramping it up by using the AWS managed streaming for Kafka as really a core component for how we're building this. So this is what we call our streaming data platform. It enables us to support our streaming data from different types of IoT sensors, real-time analytics, end-user notifications with app sync subscriptions, as well as a source for the data that goes into our data lakes. And our data lake is obviously our basis for the analytics that we're doing, and also our machine learning model, training model. So our first applications are up and running on this architecture, and they're in production now, and we're planning a full release on this in June. However, going forward, we know that cow data won't be enough to have the services that our farmers are expecting. So with the establishment of Mimiro, we've partnered with Felleskjøpet Agri, Norway's largest farming supply cooperative. And we are looking for more strategic partners that can bring us into the future as well. We see this as vital because we want to create a larger ecosystem around the farmer. So it's essential for us that we put our customer in the middle of everything that we're doing now. And Mimiro is just a year old, not even that. It's a very, very young company. So we're still learning as we go, and we see in Tina as well, working with transformation in this type of form, that there's a lot to be learned when we spin off a company like that on how we can bring the learnings back into our value chain. However, it's really important for us, and we are doing our best to stay in front of what is going on in digital innovation within agriculture and food production. So we are preparing, like I said, our first launch in Mimiro in June now, so stay tuned, because lots of new awesome services are going to become available. And going forward, our focus is going to be on our Internet of Cows. So we're going to base this on more IoTs and smart sensors, We're going to use our target architecture to offer real-time animal and farm management systems, hopefully worldwide, so that every cow can become as great as Norwegian cows, even Swedish cows. We're also testing blockchain in hopes of proving food safety throughout our value chains of both farming and food production. And we think this is going to be really important in the years going forward as well. So this was just a short sneak peek of what we've been doing the past years. I hope you enjoyed getting some insights on cows and the business development of cows. We're very much open to partnerships, like I said, so feel free to reach out to me or any of my colleagues. And by the way, we're hiring. Thank you very much.
Thank you. That was great. Thanks so much. Okay, I just want to wrap up briefly what I said before about data engineering and analytics in the cloud. I'm hopeful there's a few people in the room here that are relatively early in their technology careers that might not yet have made the big decisions about where you're going to go over the medium to long term with skills development. Would say that data engineering is a super, super hot area to get into. If you are interested in developing skills in a new field, there is a definite shortage of data engineering expertise in the industry at large. So if that is something that you feel like spending some time developing, suspect that it's something that may pay back really well over the remainder of your career. Just to wrap a little bit following Meta's comments about IoT, I wanted to just briefly touch upon services that AWS has in the IoT domain before we move on to another topic. And there's definitely a huge trend in this area for more and more devices to become connected. The latest research suggests that by 2025, there'll be over 75 billion connected devices on the planet. Okay, that's almost 10 devices for every single human being on Earth. It's a lot of software and a lot of microcontroller infrastructure that's going to be in pretty much every device that draws a current is going to end up being connected. In order to support this, we built a portfolio of services, not just one service, but a suite of services to make it really easy for customers to build, deploy, and manage connected device applications. At the core of this is a service called AWS IoT Core, which is a scalable messaging gateway with cryptographic and authentication support for messaging between edge and core. And then we have other services as well, services like Device Defender for security management of connected devices, including advanced machine learning capabilities for anomaly detection. We have device management to help you push firmware updates out to your fleet of connected devices. We have a visualization tool called the Things Graph, which makes it possible for you to figure out how devices are interrelated to one another, as well as all of the other services that you can see on this slide. It's a specialist area, of course, but we have lots and lots of customers around the world, from the wearable technology that many of us are familiar with, through to large-scale industrial infrastructure. Like Kempi, for example, in Finland. They were on stage with me here in Stockholm a couple of years ago, talking about connecting their welding infrastructure using AWS IoT for managing weld service provision to their industrial customers. We also have Telenor, a customer here in the Nordics, working on IoT operations and providing IoT solutions to their customers, as well as a company in Sweden called Delavel, who are operating in the farm infrastructure business to build connected agricultural equipment and machinery which is connected to the cloud using AWS. So lots and lots of examples of customers building IoT on the AWS platform. Now, talking about data engineering as a super hot area in IT today, in software technology today, the other super hot area, of course, is machine learning and artificial intelligence. And I wanted to spend a little bit of time talking about some of the work that we've been doing in that area right now. Amazon has been investing in AI and machine learning technology for over 20 years. And if you've ever shopped on Amazon.com, as I imagine a few of you will have done, you'll see things like product recommendations, recommended for you, or based on your purchase history. Those are features that are powered by machine learning algorithms, in that particular case, factorization machine algorithms, which operate at scale across what is an extremely large data set within Amazon.com. We also use machine learning in areas that are less visible to customers, things like optimizing our fulfillment inventory and automating our fulfillment centers with intelligent robotic systems using machine learning and AI. And then we have experimental products like Amazon Prime Air. This is drone-based delivery with autonomous flight. So the drones have ML inference models on them that enable them to autonomously avoid hazards in the physical environment during their flight operations. So they'll literally navigate around a vehicle or fly around a pylon in order to avoid hitting it, and they'll do that autonomously. Then we have Alexa, natural language understanding. It's a really good idea, a really good example actually of a product that was created to satisfy a need that a lot of people didn't know they had at the time. So who would have thought that they would be setting their alarm clock or a timer or a reminder just by using their voice in their home? But today it's completely natural, and there's a lot of machine learning technology behind that. And then most recently, Amazon Go. It's our just walk out shopping experience. Walk into the store, scan your Go app, pick up the products that you wish to purchase, and just walk out. And a few seconds later, you'll get a push notification with a receipt for whatever you remove from the store. There's no checkout, there's no barcode scanning, there's no visible infrastructure inside the retail environment other than the gate that you walk through to get in. And there we use multi-point video, object detection, and sensor fusion combined with ML to figure out what the products were that you actually chose to purchase on that particular visit. So we've been doing this for a long time in lots of different areas. At AWS, what we're focused on is putting those same kinds of capabilities into the hands of every single developer and data scientist on the planet. And we want ML to become completely pervasive so that it's not something that it's difficult for software developers or architects or even business people to think about applying and then get benefit from applying inside their particular business context. So many customers are using AWS for this type of use case today that it's just too expansive to go into them all. One example here in the Nordics is a customer called Boost.ai. They build virtual agents that help banks, insurance companies, and in this case, more than 90 municipalities in the Nordics serve customer inquiries using conversational AI at scale. So the human beings in the contact centers or service centers only have to deal with the hard problems. The simple stuff that can be dealt with using machine learning is dealt with at the first point of contact using ML. We have a breakout later today with another customer called HID Global or HID Global, also from the Nordics, here at the event today, who will talk a little bit more about their particular use case for ML on AWS, alongside our principal ML evangelist, Julienne Simon. So I recommend you get along to that session if you've got an interest in artificial intelligence and machine learning as well. So what do we have here? Essentially, there are three different layers of the stack here because there are three very distinct developer personas that want to take advantage of ML. At the bottom of the stack, you've got frameworks, interfaces, and infrastructure. In the middle, you've got a platform or a tool chain to enable regular software developers to apply their skills to machine learning challenges. And at the top, you've got really, really simple to use services that allow you to directly access human-like capabilities directly within your apps. Things like image recognition or numerical forecasting, made as simple to use as they can be with the power of the cloud and deep learning behind them. Let's just dig into these in a little bit more detail. At the bottom level of the stack, this is all about price performance, infrastructure, absolute performance, and it's about integration and optimization with important software frameworks. Okay? Here we have the P3 and the P3DN instances. These are the highest performance GPU-powered, FPU-powered instances in the cloud today. They're packed with NVIDIA Tesla GPUs. Some of the systems have more than 40,000 floating point pipelines per system. So you can run really, really large training jobs with really, really large data sets, really, really fast, get your results, figure out if you've built a model which is more effective, more efficient than the previous version, and use it if so, or iterate again if not. We're also invested a lot to integrate software frameworks at this low level, providing something called the Deep Learning Army and now Deep Learning Containers that package up all of the popular machine learning frameworks that advanced machine learning developers and scientists will use, and making them super accessible in the cloud. This includes things like integrated CUDA support. So we maintain the CUDA driver layer, which is the C++ or C abstraction for the FPU hardware, which is used by the higher level frameworks. So it removes the need for you to deal with things like deploying and patching frameworks, CUDA, and the other low-level infrastructure components that are needed. A lot of our work and a lot of the work of our customers is with TensorFlow, and we have around 85% of all cloud-based TensorFlow workloads running on AWS with some very, very large customers that I'm sure you'll recognize in a second. Snapchat, Pinterest, Intuit, Siemens, Rakuten, the very, very popular video streaming service, all using TensorFlow on AWS at scale. And one of the reasons for that is the work we've done on optimization. Stock TensorFlow will give you about 65% efficiency across a large cluster with 256 GPUs, so that's multiple machines in parallel. With our optimizations, you're going to get 90% efficiency out of those 256 GPUs, which means faster training, compressed iteration cycle, and faster time to value for your machine learning models, of course. Now, there's two distinct components to running a machine learning app: training and inference. Training is a big spiky peak of workload that happens at the beginning of the process in a lot of cases, and that's often seen as the expensive part, okay? But it's the expensive part in terms of elapsed time, so it'll cost a lot per minute or hour to run that very spiky training job that you have at the front. But then you put your model out into production, and hopefully you're going to be using it, and this is where costs accumulate over a long, long tail of usage, okay? And it's actually where the majority of costs in machine learning sit. It won't give you a shock when you see the bill, because it'll be spread over time, but it will aggregate over time to often a very substantial component of the overall cost structure. So to try to fix this issue, we've done some more innovation in the area of low-level resources, announcing something called Amazon Elastic Inference. This allows you to attach fractional GPU capacity to existing EC2 instances. So you can have part of a GPU to accelerate your particular inference workload without blocking and paying for the complete GPU resource. So it's a more cost-efficient way, can give you up to 75% savings. Later this year, we will release a pre-announced semiconductor capability called AWS Inferentia. This is a special purpose semiconductor product that we've developed within AWS to reduce the cost of inference by about 10x. So that will come later this year. And then also coming soon, we have a new G4 accelerated instance family, smaller GPUs, which are good for smaller scale training or inference workloads where you don't want to block an entire P3 and have the costs associated with running that really large piece of hardware, large resource. In this middle layer, for me, this is probably the most interesting part of AWS's machine learning offerings, and it's interesting because I started my career as a software developer, and I've discovered that I can build, even in the late stage of my career where I don't actually touch that much code anymore, I can build machine learning apps using Amazon SageMaker. It's a really simple tool for non-ML developers to put their skills to work in order to build machine learning apps. And what it tackles really are the three phases of the machine learning model lifecycle: building models, training models, and deploying models. In building models, we support data preparation with Jupyter Notebooks, back to those data engineering skills. We support labeling with a service component called SageMaker Ground Truth. So using this service component, you can issue labeling jobs to workers. In the context of, say, self-driving cars, you'd be issuing frames, which are photographs of road scenes, and you'll be getting your workers to highlight the planar road surface, the vehicles, the pedestrians, the road signs. From that labeling work, you'll get back a data set, and you can then use that data set to train an image recognition or navigation model for a vehicle. So that's how it would work in practice. And Ground Truth is the framework that we provide for specifying and shipping those labeling jobs out to your workforce for them to work on. And by the way, those workforces can also be private. So in the medical use cases, for example, like image recognition with X-ray data, I'm probably going to have radiographers or even consultant physicians labeling the data. I can also establish a private workforce with Ground Truth and solve for that kind of use case as well. And then on training, over 14 built-in algorithms packaged as Docker containers that you are able to very quickly and easily spin up training jobs with prepared data. And those training jobs will be billed by the second as they run on the resources, and then your models will get deposited in a specified location within Amazon S3. You can pick up those models, and with a single click or API call, you can deploy that model into production for inference. And when it's in production for inference, it will auto-scale, self-heal, and have metrics delivered from it about performance as well. Because it's a complete tool chain for going from an idea, recurrent model training, iterative model training, to getting those models out into production for your app. Really easy for an experienced software developer to get started with ML. And we have lots and lots and lots of customers that have adopted this. Remember, this service has only been around a couple of years, and we already have over 10,000 customers that are using it, including a company here in Stockholm called Daniel Wellington, which is an online watch retailer. They've sold over 11 million watches online since 2011. They use social media very, very extensively in their business, and they use SageMaker to predict the impact of social media campaigns. What kind of ad should I run? What's the return going to be on that ad based on data from historical ads of a similar type? That's essentially the use case that they have. Then we have Formula One racing, we have Intuit, we have a host of other customers that are using SageMaker today to simplify the process of building machine learning models. The top of the stack, this is all about simplicity, okay? So how can we make it as easy as possible for a non-machine learning developer to integrate AI features? And when I talk about AI features, I'm talking about human-like capabilities. So just a few years ago, to analyze an image, you would need a person, right? You'd need a pair of eyes and a human brain, probably a mouth to tell you what was in it. Today, you can do that automatically using pre-trained deep learning neural network models that are hosted behind the Amazon Recognition Image or Amazon Recognition Video API endpoints. Submit us your encoded JPEGs or PNGs, and we will tell you what is in the image. We can do face analysis, facial comparison, content moderation. Should this image be shown? Is it safe for work or not? Should it need to be reviewed by a human moderator? These are all features of recognition. We also announced recently something called Textract, which is a deep learning powered document analysis service. OCR is a kind of well understood field, but when documents have mixed formats with images or tables embedded within them, it gets a lot harder to use OCR technology. A Textract solves that problem by using ML to learn about the structure of documents and to extract data in these more complex formats autonomously. Then we have speech and language, a portfolio of services for generating speech or understanding speech, including some special services for use in the medical field. And then we have two brand new services that are currently in preview that we have pre-announced. Amazon Forecast. This is accurate time series forecasting. Again, it makes use of deep learning technology to build very capable forecasting models with a very, very easy to use interface. That's currently in preview. And then secondly, personalize. This is based on the same kind of personalization and recommendation technology that is used within Amazon.com for that you might like based on your purchase history type feature that I talked about at the top of this particular segment. Again, that's in preview and it'll be made available to customers quite soon. So this democratization of machine learning, I think, is going to have a big impact on software and technology over the course of the next few years. And to talk about one organization that is making use of this effect in order to build what I consider to be incredibly innovative and exciting products, I'm really excited to invite my next speaker to the stage. It's Jan-Erik Solem. He's the CEO and co-founder of Mapillary. Jan-Erik, please join me.
Good morning. Thank you for the very nice introduction, Ian. I'm super excited to be here this morning to talk about Mapillary. My name is Jan-Erik. I'm a computer vision geek, researcher turned entrepreneur, and now CEO and one of the co-founders of Mapillary. So imagine if you could build a digital, complete representation in 3D of the world. A one-to-one map of every location, down to the individual objects in their location, like the streetlights you see on the screen here. This is what we have done with Mapillary. It's a platform that can take images, street-level images, from anyone in the world, from any camera, combine it together into a representation that we can mine for data. Understanding and map data from these images are then published and available for everyone to use, like the features you see on the map here. So, I believe we live in very, very exciting times. It's the first time in human history where we are able to build a complete representation of the world at scale for the first time ever. And the components and tools for that, there are 3 things that make that available that have arrived fairly recently. So the first one is cameras. So yeah, the camera is not a new invention, but it really didn't become available at scale until the smartphones arrived. So we have about 2 billion smartphones out there in the world today. They're all connected. We have about 1 billion cars that are becoming increasingly connected, and they're all going to be equipped with cameras. On every street in the world today, there are the tools that can generate that representation and keep it fresh and updated. It's already out there and deployed. The second thing is what you heard now, is computer vision, artificial intelligence. If you've been following the boom in deep learning, all of the things that have happened in the last 5 to 10 years, a dramatic increase in performance, in recognition, in things like you saw on the screen just now. And the third, cloud computing. It wouldn't be possible without that, and I guess it's why both you and I are here today. So you might think that this is some kind of futuristic, crazy scenario, but it's not. It's actually been running live for about 5 years now. Mapillary as a platform is available globally. We have images in every country in the world, and the data is available on our website and in lots and lots of third-party integrations for everyone to use. And primarily, it's being used by mapping companies, both the small regional ones and the global players. It's being used by automotive companies to train their perception systems, to run self-healing map prototypes, and it's being used by cities and smart city initiatives worldwide. So the output from this platform, there are 3 things coming out the other end. One is this image representation that you can move around and explore places in 3D, but the images come from uncoordinated capture from many, many different individuals, like the ones you see on this animation here. The second thing is every pixel in every image is indexed with object recognition, and it's searchable. So you can go in and look for images in Germany containing guardrails, for example, if you're interested in that. And for things that are stationary, that we see in multiple images, we also triangulate and position them, and then they become map features like the one you see here. So here's how it works. We get images from any camera anywhere in the world, and we don't control when that happens. And our job is to take that imagery and turn it into insights and data as quickly as possible and publish that. And to do that, the images come straight into S3. But since we need to support many, many different types of cameras, and some of them have strange formats, there's also lambdas running there, handling some custom formats for specific cameras. And then there's this processing pipeline of different computer vision operations that we run on the images. We do privacy blurring, faces, license plates. We build this 3D reconstruction you saw, traffic sign recognition, object recognition, lots and lots of indexing. We serve this data in the format of map tiles, blurred images, and through APIs. And all of the tiles are stored again on S3 and then served out through CloudFront. So it might look simple in this very abstract, high-level representation, but it's actually over 160 different apps running in our backend with over 200 deploys every single day to keep this machinery running. So to put some numbers on it, it's about 11 billion objects in S3. 56 billion image regions have been labeled and indexed and made searchable. And we spent about 17,000 spot instance hours to produce that data. All right, so let's look at a concrete example of combining the 2 platforms, the Mapillary platform and AWS. Parking signs. So what we're great at Mapillary, we were great at finding traffic signs in images. We're great at positioning them, giving you the latitude and longitude of here's a parking sign. But it's not very useful information unless you also know what the sign says, right? You need to understand the regulations encoded in the sign. And so here's what we did. So we combine our traffic sign recognition, and then we run recognition, Amazon recognition, to do OCR on the text on the sign to decode the parking regulations from those crops in the images. So the pipeline is the same. You get images in, we store them, we run traffic sign recognition, we pick out all of the crops that contain parking signs in this case, we feed it through recognition, and then we add the text as additional metadata out in the API response related to those specific objects. All right, so one of the things that our customers ask us all the time is, how can we complete coverage? How can we get new images, new data, fresh in the areas that we care about? And how can we get those updates? So I'm actually super excited now to announce today we're launching the Mapillary Marketplace. It's live now, as of right now. Whoa, yes, thank you. And what it means is that it means that anyone on the demand side of our platform can now, in the US and Europe to start, go out and publish their demand in the form of requests. And anyone in the Mapillary contributor network can go in and solve those capture problems or verification of data for that customer. And we think it's going to be the next dramatic step in scaling up and accelerating image updates and map data updates around the world. So it's live today. I'm super excited about that. And that's all I had to say today. I hope it was valuable for you guys. Enjoy the conference, and thank you so much.
Something great about seeing customers launch new innovations at an event like this. It really gives me a thrill to see that. And I hope that you experiment with Mapillary's new service offering and give it a try. Fantastic. So I hope you're enthused now and you want to learn more about how you can get started with machine learning. And I'm just going to quickly recap some of the resources that we have to help you go on this journey, or maybe take your teams on this journey in taking advantage and exploiting some of these new capabilities that are available today. As Jan-Erik from Mapillary mentioned, there's a confluence of factors here which mean that it's never really been easier to put ML to work. But how can you get started? Okay. The first thing is we have something called the ML Solutions Lab. This is a consulting service that we use to pair customers with Amazon machine learning experts. So if you've got a problem that you want to solve, but you don't have the expertise in-house to do it, then we can help you through the ML Solutions Lab. And you should talk to your AWS team if you're in that particular set of circumstances and you want to move forward with that. If you're interested in building up your skills within your organization, we've also made the training used by Amazon's own internal developers available to you as customers through the Amazon Machine Learning University. You can access a set of training and learning paths that developers can use to upskill themselves on this really, really important area of innovation. So you should experiment with that. It's accessible via the AWS website, and I'll show you a link where you can jump off to it at the very end of this segment. That's a bit theoretical, okay? So what about some practical things? We also have a couple of actual physical products that we've created to make it easier for developers to literally get hands-on with AI and ML capabilities. The first is the AWS Deep Lens. It's the world's first deep learning-enabled video camera. You can train image recognition or image classification or object detection algorithms, models using algorithms within Amazon SageMaker, and then you can deploy those models down onto the device for local inference. The device is available on Amazon.com. You can purchase it, and within about 10 minutes, you can have your first image recognition machine learning model up and running on a Deep Lens device. So I'd encourage you to take a look at that and experiment if you're interested in that particular field of ML, image processing, image recognition, object detection, scene detection. More recently, we announced something called the AWS Deep Racer. This is, I think, a really, really interesting concept. It's a fully autonomous 1/18th scale racing car. It uses technology from one of the hottest emergent areas in ML, which is reinforcement learning. You can train your model in a simulated environment, deploy that model onto the car, and then have the car race and compete against other people that have undertaken the same process. To show you a bit more, I think we've got a short video that we're going to play out for you now.
Hello everyone, I'm Ryan Marine. These are 1/18th scale RC cars that are fully autonomous thanks to reinforcement learning.
So you can participate in this event here today in Stockholm. We have the AWS Deep Racer League. It's deployed in the expo area here at the summit. And I happen to know, hot off Twitter, Cybercom, who are an AWS partner in Finland, who happen to also be the organizers of the AWS user group up in Helsinki, are currently in first place on that leaderboard. Okay, and I'm going to appeal to everybody in this room to go and beat Cybercom. Spend some time, experiment with Deep Racer, and take part in the league. The winners get a free trip to AWS reInvent 2019 in Las Vegas at the end of the year. They get to compete against all of the other winners from AWS events globally, and you get to win a huge, very, very ostentatious trophy if you come first. Importantly, though, you can also participate in this series remotely. There's a virtual racing league. You can train a model, run the model within the simulator, within the Deep Racer console on the AWS platform, and compete from the comfort and safety of your own office, bedroom, or studio. So take a look at Deep Racer. It's awsamazon.com/deepracer. All the information about the competition and access to the console where you can train your first model is available there. And we aggregate all of the resources about AI and machine learning at Amazon at ai.aws. If you visit this really easy to remember URL, you'll find a link to the Deep Learning University that I talked about. You'll find information about all of the services that we've covered in this segment. And I would appeal to you all to spend some time developing your skills in this really, really hot emergent area of software technology today. I think it's really interesting and pretty much guarantee that that investment will pay back over time. Okay, so I'm going to wrap up here. I want to thank you for joining the keynote this morning. I really sincerely hope that you enjoy the rest of the day. As I said earlier, we've tried really hard this year to increase the technical depth in the sessions here. But as always, we would love to hear your feedback. We hope to prove to you, if you're a new user of the cloud or not actively using AWS today, that you can build on AWS just as effectively as those customers here that might be more experienced. I would personally love to hear your feedback about the session this morning. If you've got any feedback on the keynote, you want access to any of the resources that you've seen, you can reach me at ianm@amazon.com or find me on Twitter. Thank you. Have a great, great day.